Hello everyone, welcome back to the tutorials again. So in today's session, in previous session we were discussing about the examples on consolidation. So we have almost discussed 8 to 9 examples on consolidation. So in today's session we are going to discuss about the examples on compaction. So before exactly moving to the examples on compaction, I would just like to briefly repeat the things are the basics which are needed to solve the problems. So we are going to solve the problems on standard as well as modified Proctor test. So just let us try to understand what are these tests. Actually, we have discussed about these tests previously in previous sessions. So you can see over here. So standard Proctor test and modified Proctor tests are the tests which are used to determine the optimum moisture content and maximum dry density. What is optimum moisture content? Optimum moisture content is the moisture content in the soil. At that moisture content we can compact the soil till maximum dry density. I will give you the example. If you take the dry soil and if you try to compact it, the compaction will be very less as compared to wet soil. But if you go on adding the water, let us add small amount of water, the compaction will be better in that case. Again increase the water, compaction will be again better. Again increasing the water will make the compaction much better. Similarly, at one point we reach the water content, we go on increasing the water content and we reach the water content at which we can achieve the maximum compaction. Achieving the maximum compaction means what? Achieving the maximum dry density or maximum density. So after achieving the maximum dry density or density, now how we can able to identify it? Further adding the water will cause the density to decrease. So at that point we have to understand that we have reached the maximum water content, that is maximum dry density or maximum density and optimum moisture content. So optimum moisture content we have reached and maximum dry density we have reached. So that maximum dry density and optimum moisture contents are very much useful while doing compaction in the field. So how they are useful? In the field, if there is a large area and we need to compact it, let us consider a road construction. So while constructing a road, we need to compact the soil first. So how much amount of compaction we have to do, uh, how much amount of water content we have to maintain for the compaction to achieve the maximum compaction, those are the questions which comes into mind. So for that purpose, on the same soil sample we are going to conduct the standard and modified Proctor test to find out the amount of water content which we have to add and uh, amount of water content which we have to add and amount of compaction effort which we have to try. So let us study about standard Proctor test. Both the test procedures are similar, but just a few things are going to change. So let us first study about the uh, Proctor test, standard Proctor test. So these are the equipments. This is the mold, this is the collar. So this is the collar, this is the mold. Dimensions of the molds are given over here. Similarly, dimensions of the column is also given over here. So this is the hammer which is there. So height of drop will be 10 mm, diameter will be 50 mm. So now you can see here procedure. Take about 3 kg of soil. I'll just show you the test equipment. So this is the modified Proctor test equipment, this is the standard Proctor test. It will be a little bit smaller. This is the collar, this is the mold, and this is the hammer, this is the hammer. So these are the equipments. Next you can see, take about 3 kg of sample which is passing through 4.75 mm sieve. So add start from 4% of water content for fine grain and 8% for coarse grain soil. Next, soil is mixed thoroughly and kept for 15 minutes. So the mold is cleaned and we have to place the soil in 3 layers. Each layer will be compacted with 25 number of blows. Weight of height of drop of hammer is 310 mm. in 3 layers. Weight of hammer is 2.6 kg. 310 mm height of drop in 3 layers we have to compact. After compacting, we have to find out the bulk density. So we know the mass of the uh, after compacting we have to take the mass of the mold. We have to remove this collar, we have to remove this collar, we have to detach it, and after detaching we have to take the mass of this particular uh, soil and mold. Empty weight, if I subtract the empty weight, then I am going to get mass of this particular soil sample which is there in the mold. So I know the volume of this mold, so pi d square divided by 4 into height. If I do, I can able to calculate the volume. So mass divided by volume is going to give us bulk density. So like this I have to calculate the bulk density. Further you can see by using this I by using this bulk density, and after that representative soil sample I have to keep it for water content determination. For water content determination, and I have to find out water content. If we know the water content and bulk density, I can find out dry density. Similarly, we have to go on increasing the water content from 8% to 10%, 12%, 16%, like that, and at until the dry density decreases for a particular set of values. For example, I have go on increasing the water content from 8% to 10%, dry density increase. Similarly, 10 to 12 increased in dry density was observed. 10 to 14 increase in dry density was observed. Similarly, 14 to 16 now decrease in dry density was observed. So till then we have to continue the test and we have to note down the readings. Now after that, water content is on x-axis and dry density is on y-axis. I have to plot the curve. I have to plot the curve, and whatever the peak point of the curve is there, I have to mark that peak point, and I have to mark the y x-axis, and this x-axis is whatever the water content is there here, it is going to give us the optimum moisture content. Whatever the water content is there here, it is going to give us the maximum dry density. So this is called as MDD, that means maximum dry density, and this point is going to call as optimum moisture content. So this is what I wanted to explain. But further you can see there is something called zero air wide line. There is something called zero air wide line. So zero air wide line, or we can call it as a 100% saturation line. So there is one point where the degree of water content are there is degree of saturation is 100%. At that point there will be no air voids which are going to remain. So whatever the water content is there, for that water content respective dry density we are going to calculate, and we are going to draw a we are going to plot the curves in the on the uh, graph, and that is going to give me the zero air wide lines. That is going to give me the zero air wide lines. So for zero air wide lines, that's what I have said. You can see here s is equal to 1, so na is equal to 0, because na is equal to 0 because there is no air wide remains, and s is equal to 1 because it is 100% saturation. So this part is going to get vanish, even this is going to get vanish. So the formula for zero air wide line is mu d is equal to g into mu w divided by uh, g into mu w divided by 1 plus small w into g. So this is the formula for zero air wide line. So we'll move back to the problems. So this was the problem which I wanted to discuss. You can see here, so examples on compaction. Following observations, this problem is from your previous year question papers. So it was asked in 2015. Following observations were made in standard Proctor test with mold volume of 945 cc and G is equal to gram centimeter cube, and G is equal to 2.67. So trial number 1, mass of wet soil they have given. Mass of wet soil means empty weight of mold they have subtracted to the final weight, and they have given mass of wet soil. Water content also they have given for respective trials as we have discussed. So trial number 1, 1.7 is a weight of wet soil, 7.7 is a water content, 1.89 weight of wet soil, 11.5 is the weight of water content. Similarly 4, 5 and 6 trials they have conducted. Okay, now determine the maximum dry density and optimum moisture content, and also plot the zero air wide line. This is very important. Also plot the zero air wide line. So for this purpose, what I have to do to determine the maximum dry density and optimum moisture content, I have to plot the graph. I have to plot the graph on x-axis. I have to mark the water content or moisture content. I have to mark the water content on x-axis, and dry density on y-axis I have to mark. On dry density on y-axis I have to mark. So for that purpose I need to calculate dry density. So water content I am having, I need to calculate the dry density. So I will just plot the table. So G they have given in the problem. So G is 2.67, volume of the mold is 9.945 centimeter cube. So now I, before calculating mu D, I need to calculate bulk density. As it is a wet soil, I need to calculate the bulk density. Bulk density means weight of wet soil divided by volume. So weight of wet volume of the mold will remain same. Weight of wet soil they have already given. So I have converted it in grams. So weight of wet soil, water content, trial number, mass of the soil, water content mu B means bulk density. So bulk density is equal to weight of wet soil divided by volume. So weight, the first calculation is here. So weight of wet soil is 1700 grams divided by volume is 945. So it is going to give me 1.8 gram per cc. Similarly, second one, 1890 is the 1890 is the weight of wet soil divided by volume. Volume will remain same, so it is going to give me bulk density for second trial. Similarly, you can observe here at this particular point the bulk density has increased, but after this the bulk density has decreased. So as we increase the water content till here, the bulk density increased, but after this point bulk density decreased. So we have conducted the test properly, it says. Next, I need to calculate the dry density. So how I can calculate dry density? Dry density can be calculated like this. So 1.67 is the dry density for first trial. So you can see dry density is equal to bulk density divided by 1 plus water content, 1 plus water content, which is equal to 1.8 divided by 1 plus 0.077. 0.077 is a water content for first trial. 7.7% means 0.007. So for by using that I can get the dry density as 1.67 gram per cc. Now how about zero air wide line? So third row will be of zero air wide line. So zero air wide line is like this. You can see calculation is like this. For zero air wide line, zero air wide line, zero air wide line formula is like this. We have already seen this formula. G into mu W divided by 1 plus water content into G. So for first trial you can see G is 2.7, mu W is 1, as it is in gram per cc. Remember, mu W is equal to 1 gram per cc or 1000 kg per meter cube or 9.81 kilonewton per meter cube. So I have substituted all the values. For first trial 0.077 is the water content, and I have got this value. Similarly for second trial I have to substitute this water content. I am going to get this value. Same way I have calculated all the values for this. So just briefly about zero air wide line formula I have given over here. So after calculating all these things, on x-axis I have to keep water content, on y-axis I have to keep dry density, and I have to plot this curve. By marking all the points. So whatever the highest point is there, that highest point I have to mark I have to draw a vertical line, I have to draw the horizontal line. Wherever this horizontal line touches, that point is called as maximum dry density. Wherever this vertical line touches, that point is called as optimum moisture content. So it is touching somewhere over here. So it is touching somewhere over here. So 14.5% is the optimum moisture content and the maximum dry density is 1.88. Now how about zero air wide line? All the values we have already calculated over here. So for drawing the zero air wide line, we have to consider this water content and we have to consider this row on y-axis, this row on x-axis. So I have to draw the line and this line is called as zero air wide line. Sometimes there is 80% saturation line. Sometimes there is a 80% saturation line. Similarly, which they have asked in next problem, plot 80% air wide line or 100%, 80% saturation line and 100% saturation line. 100% saturation line is nothing but zero air wide line. 80% saturation line is nothing but uh, S is equal to zero point 0.8 we have to consider. So S is this one will be the additional row because S is equal to 80% we have to take. So this is the calculation for that. So S is equal to 80% I have to substitute. S is equal to 80% I have to substitute for all the values and I have to find out the answer. So this will be the graph for that. So please go through this. If you have any doubts, please contact me. So with this, we are going to end up with module number 4 and mm, in next session, I am going to briefly discuss about the syllabus which is covered, syllabus which is remaining, and we are going to move forward to solve. We are going to move forward with next units. Thank you.